again, Thursday the 16th is today. So, hello everybody. What's out? What are we working on this week? Tonight.
The standard.
Standard. What's standard about this week? Amelia. Exploring Earth's atmosphere. Amelia. So why are we doing this work? Why are we doing this work? Why?
To help us better understand what causes us to be able to survive on Earth.
That's a good response. True? Or that's different than what you might have said. True? And that was the reason why I wanted to kind of just hear a different spin. Okay? There's a lot of reasons why this is useful. All right? So, how are we going to explore information? How are we going? So what is this thing right here? Look at the screen, ladies and gentlemen. What is this thing? Somebody connect. Go ahead. Look.
Standard? No.
What is that? What is that? It's a strategy for studying science. True? You investigate. You have a phenomenon, right? Right? So look and pay attention. You see 5E and then you see 5 words that start with E. Correct? So what are we engaging? Starts with a P. What's the engaging part? Starts with a phenomenon. We're going to be engaging a phenomenon, correct? After we engage this phenomenon, we're going to do some sort of exploration about the phenomenon. Right? What is the phenomenon that we've been talking about the last few weeks? Someone else in addition to, go ahead, young lady. If that were the case, what would be the thing about it? What's the relationship between gravity and what we're studying? Anyone remember that? Amelia?
Inertia.
What about it? What about those things connects to, what's the main topic for today? Starts with an A? Yeah, say it, Morgan. So what's the relationship between gravity and atmosphere? Go ahead.
Gravity holds down the atmosphere.
Gravity, Earth's gravity is holding the atmosphere in place. Are we clear? So, what we just did was an explanation of some of what we've already started talking about. You see how the words sort of flow together, even if we don't have them planned out meticulously? Okay? Then we would elaborate on these concepts. That's what we're going to be doing today. We're going to get more and more into it. And then you have little questions and so forth along the way that are embedded in the work itself. Are we clear? Okay. So let's go back over to the agenda. So back at the agenda, the standard, we got our standard as usual. What I want to communicate about the standard, Jameer, read the first part here for me.
Plans carried out in investigation to illustrate the role of the sun's energy and atmospheric conditions that lead to the cycle of water.
Stop, please. So atmospheric conditions that lead to the recycling of water. So I'll give you about 15 seconds on your own. Think of some ways that atmospheric conditions lead to the recycling of water. I'll wait. Think to yourself some conditions that lead to the recycling of water. Okay, Quinn, you got any ideas?
The atmosphere, because of the clouds, it cools the water down.
Because of the clouds, the atmosphere can cool some of the water down. Leonard?
Whenever the sun evaporates water, the water vapor turns into clouds, and some water that's too heavy will fall, making it rain, and then it will restart the cycle.
Everybody clear on that? So, What about the water that's in my thermos right here? How is that a part of the process? So let's give a different one. So let me ask you all a question. Caleb, if I put a cup into the microwave and I put the microwave on 4 minutes, and it was just 1 cup of water, but it's on 4 minutes, what's going to happen to the water?
It will evaporate.
All of it or some of it?
Some of it.
Some of it? Okay. What's going to happen to it along the way? Is it just going to be water the whole time and then it's gone? Dante, what's going to happen? You want some help?
No, I was gonna say something that I think that's stupid.
Go ahead. That's okay.
The water might start boiling.
The water will start boiling. He said it might start boiling. It will start boiling, true? That's why I said 4 minutes. We know it probably takes less than that for it to start boiling. Okay? Amelia?
I forget the exact word, but the steam will turn into water.
The steam. So let me give you another scenario, an additional scenario, okay? So we got a cup of water, let's say 6 minutes, microwave, okay? And we put a piece of paper over top of the water, over top of the cup. What's going to happen to the piece of paper? Ava, what's going to happen to the piece of paper?
It's gonna get wet.
The piece of paper is going to get wet. Oh, it's clear about that? So what if we had a piece of wax paper? Wax paper, June. You got a piece of wax paper over a cup that's in the microwave. And the water's been in there. Microwave's still going at 7 minutes. What's going to happen to the wax paper? With just regular paper, it will get wet. What's going to happen to the wax paper? You ever seen that before? You ever cook? You don't cook? Okay. Go ahead, Sanai.
We don't know.
It might start to melt, but before it starts to melt, what's going to happen? The droplets are going to form. Leonard, focus on me, but I still want you in conversation. The droplets are going to form. So what if there was what if that wax paper had a drop of grease from my food that I previously had on the wax paper? Now what's going to happen? Anything? There's some grease from some food and you got, what's the process that changes the water into what ends up at the bottom of the paper? Go ahead. Starts with a E. It sort of evaporates, but it's being caused to evaporate from the heat energy from the microwave, right? Then what happens once it gets to the bottom of the paper? Engage me, folks. What happens when it gets to the bottom of that? That evaporation hits it, and then it does what? Go ahead. Condensation. So if there's something there, some other material, another minute or so goes by, what's going to happen to those droplets? Are they just going to stay there? What's going to happen? Go ahead, Ari.
It's soon gonna become so heavy because of how many water droplets form and connect. It's soon gonna become heavy enough to drop or fall.
What's the it that you're referring to? You know, it's the same thing. The water, the droplets, right? You say it. Well,
The droplets will fall.
because they become too heavy. Y'all got that? So that is actually what is here in the standard. Plan and carry out an investigation to demonstrate how energy from the sun transfers heat. This isn't the sun, but we're emulating that process, true? And it ends up doing the same thing. We can cause evaporation, condensation, and then precipitation inside of a cup. Next. These things here, this is again what's being talked about. That's the little process. That's one of the processes that we just discussed. So if you're asked this on a test, can you plan and carry out an investigation to demonstrate how energy from the sun transfers heat through the air? You could say, well, I don't have the sun, but even if I took a cup of water and set it outside on a 99-degree day, at the end of the day, this process would happen. Do you all agree or not agree? Speak up, ladies and gentlemen. Okay. So next, let's get through it. Our I can statements and so forth, they're the same. We've just been actually talking about these things. Construct an explanation of relationship. What's relationship between the wax paper on a cup and water in the cup on a day that's 100 degrees outside? What's the relationship there? We just discussed that, correct? Let's go on to our work for today. What's in blue are our resources. What's in blue are our resources. NASA site, a different NASA site that shows the layers of the Earth's atmosphere. But for today, we're going to go and do an activity in Nearby, and it includes everything that we need to work on. So let's go there. You're going to be able to work with the people who are next to you. I'm going to exit this because we want our own individual one, and this one is for the last class. So give me a moment to pull it up. In the end, either way, you're going to Nearpod, and we're going to be going to Earth's atmosphere. And today we're going to do the student pace. Okay? Here's your new code. Make sure that it's done what I want it to do. Because that's our code. That's our code for this block today. K4 UJ5. K4 UJ5. Anyone have any trouble getting there? Hold up your hand. Raise your hand if you have any issues getting in. Raise your hand, please. Everyone's fine? Okay. Then get started. And you can work together. You can work together. You can talk with the folks who are next to you. And I expect you to be talking. You can work together. You can talk. So keep doing it. Keep me out as much as you can.
Oh. Yeah, I know. It's hilarious.
I expect everyone to be communicating with the persons next to them. If you're not, that's problematic.
Strontosphere? Yeah. Do you want me to get my notes out? Oh.
So you're going to need paper and pencil for some of these questions to keep track of the information. Paper and pencil, folks. Paper and pencil, gentlemen.
I can't pronounce it. Okay.
You're not going to be able to keep track of everything in your head.
So. Okay.
You'll notice the lesson is set up in the same framework.